This is lesson 29 for 7th grade, and today's topic is rounding with whole numbers and mixed numbers. And we're also going to be estimating some answers. So this is some stuff that we've seen before, but we're going to use things that we've already seen and apply some new things, or use things that we've learned this year with these things. So let's just jump right into this lesson here. Alright, we're going to start with this statement here. The first sentence below uses an exact number to state the size of a crowd, and the second sentence uses a rounded number. So, exact, there were 3,947 fans at the game. And if we wanted to round that, say there were about 4,000 fans at the game. So, 3,947 is close to about 4,000. So, they rounded up in this example. It says sometimes we can use, rounded numbers are often used instead of exact numbers. And sometimes one way that we can round is to do that on the number line. Alright, so if we look at 283, we can round that to the nearest 100. We could also round that to the nearest 10. So if we use a number line, which we probably won't do this one too often, but it helps us see why we round up or down. Alright, so to the nearest 100, that would be here. We're either going to round to 200 or to 300, whichever it's closer to. And we can see that 283 on the number line is far closer to 300 than it is to 200. So we would round this up to 300. Alright? But if we look at 283 to the nearest 10, that would be here. This is our tens place. This is either going to round down to 280 or go up to 290. This one on the number line is closer to 280 than it is to 290. So we're going to round it down to 280. Let's see if I have a better marker here. I'll bring out a few just in case this has happened before. Alright, rule of thumb is if you're over halfway, or if you're at halfway or over halfway to a number, you're going to round up. If you're less than halfway to that number, you're going to round down. And we're going to get into that in a second here. We're going to use the same two numbers. And it says sometimes we're asked to round a number to a certain place value. That's what we just did. We can use an underline and a circle to help us do this. We will underline the digit in the place to which we are rounding, and we will circle the next place to the right. And then we're going to follow these rules. If the circled digit is 5 or more, we add 1 to the underlined digit. If the circled digit is less than 5, we leave the underlined digit unchanged. We replace the circled digit and all digits to the right of the circled digit with zeros. So that might sound a little confusing, but let's use our two examples here again, without the number line this time. So it says round 283 to the nearest 100. Well, we're going to write 283, and it wants us to round to the nearest 100. So we underline what they're rounding to, and we circle our 8. Now, if the circled number is 5 or more, we add 1 to the underlined digit. So we're going to add 1 to 2 because this is higher than 5. So 3. And it says we replace the circle digit and all digits to the right of the circle digit with zeros. So 300. So we still get the same answer as we did with the number line one, except for we didn't have to do a number line. This took a lot less time. Now if we look at 283 to the nearest 10, that would be, tens place, 283. We underline the tens place, and we circle the one to the right. Our circled number is less than 5, so this stays the same as an 8, and this turns into a 0, 280. So we still get the same answers as we did before, but it takes a lot less time. So this is typically the way that we will round. It's just a lot faster. Hopefully that's something we already know how to do. And if not, we have been reminded how to do it. Okay, so let's look at this example here. round 5,280 so that there is one non-zero digit, okay? So we only want one digit that is not zero. So that means we're actually going to be rounding to the thousands place. We're going to round to this place, and we're going to look at the next digit over there. So we're going to say, okay, 2 is less than 5, so this is going to turn into 5,000. So that's rounded down to 5,000. Okay. Here's a better example. Round 93,167,000 to the nearest million. So we're going to underline our millions place right here. Circle that. Our circle number is less than 5, so this will be 93 million once we round. Alright. So far so good. Okay. Now the other type of number that we've been working with is a mixed number. So we're going to round mixed numbers to whole numbers, and in order to do this, we need to determine whether the fraction part of the mixed number is greater than, equal to, or less than 1/2. So if the fraction is greater than or equal to 1/2, we're going to round the mixed number up to the next whole number. If the fraction is less than 1/2, the mixed number rounds down. A fraction is greater than 1/2 if the numerator of the fraction is more than half the denominator. A fraction is less than 1/2 if the numerator is less than half of the denominator. So we're going to have to be able to determine whether our fraction is greater than or less than 1/2. So round 14 and 7/12 to the nearest whole number. Well, let's look at our fraction part. Is that greater or less than 1/2? Well, half of 12 is 6. And 7 is greater than 6. So 7 out of 12 would be greater than 6 out of 12. That's greater than 6 over 12, which is 1/2. So 7 over 12 is greater than 1/2. Since this is greater than 1/2, we round up to the nearest whole number. This would be 15. Okay. Moving on. Rounding can also help us estimate the answers to arithmetic problems. Estimating is a quick and easy way to get close to an exact answer. Sometimes a close answer is good enough, but even when an exact answer is necessary, estimating can help us determine whether our exact answer is reasonable. One way to estimate is to round the numbers before calculating. So if we look at this here, oops, sorry about that. It says Barb stopped by the store on the way home to buy 2 gallons of milk for $2.79 per gallon, a loaf of bread for $1.89, and a jar of peanut butter for $3.15. About how much should she expect to pay for these items? I use this all the time when I'm shopping so that I can determine about how much money I'll be spending. So she's buying 2 gallons of milk at about $2.79. Plus a loaf of bread for $1.89, plus a jar of peanut butter for $3.15. Adding all that in our heads would not be the easiest thing to do, so we could round. We want to round to the nearest dollar. So this we would do underline 2, and look at 7. That's going to round up to $3. So really we've got 2 times 3 plus, that's greater than 5, so $2 that would round up to. Yeah, I suppose I could put the zeros here. And, oops, I want to underline that one. My fault. 1 is less than 5, so. Alright, so now we have 2 times 3, which is 6, plus 2 is 8, plus 3 is 11. So about $11. I'm going to check my time quick. Alright, now the keyword, and we don't want to ever estimate unless they give us a keyword or to actually say to estimate, but here's our keyword. It says about how much should she expect to pay. If it asked us the question, how much should she expect to pay, we should get the exact answer, but this about changes the whole thing. We're saying that we're allowed to ballpark our answer or estimate. So about is the key word there that says that we can estimate the answer. Alright, next couple examples here. And I'm going to go through these quick because I'm running out of time. So 5 7/10, we're going to mentally estimate these. 5 7/10, this is bigger than 1/2 because 5 out of 10 is 1/2. So this would round to 6 times 3 1/3. 1.5 is half of 3, so this is less than a half. This stays at 3, and we should get 18. 6 times 3. And that's if we estimate. These aren't the exact answers. 396, I would round this one up to 400. That's bigger than 5. And I would round this one down because 1 is less than 5, 300. And we should be getting 4 times 3 is 12 plus 4 zeros. 120,000 there. And lastly here, I would round this to the nearest 1,000. Round this down to 4,000. Round this up to 20. 4,000 divided by 20, the same thing as 400 divided by 2, which is 200. So those are your estimated answers. And lastly here, if we look at, I'm going to check my time again real quick. Alright, we got about 2 minutes. So Eldon calculated the area of this rectangle to be about 25 1/4 square inches. Is Eldon's calculation reasonable? Why or why not? Well, this is what he got for an answer for the area. Let's round and see if we get anywhere close to that. And 7 3/4. 3/4 is bigger than 1/2 because 2/4 is 1/2 and 3 is bigger than 2. So this is about 8 inches. 4 7/8. 7/8 is bigger than 1/2 because 4 is half of 8 and 7 is bigger than 4. So this rounds up to 5 inches. And just by estimating, we find area equals length times width, which is 8 inches times 5 inches, which is 40 inches squared. And Eldon got 25 1/4 square inches. I would say his calculation is not reasonable because 40 square inches and 25 1/4 square inches are not close at all. So his answer is not reasonable. Alright, so that was our lesson 29, and we'll see you tomorrow.